In this problem, for a positive integer n, there is a quadratic equation x into x plus 1 plus x plus 1 into x plus 2 so on plus x plus n minus 1 into x plus n. See, individually all these are quadratic equations. Together if we add them, the result also should be a quadratic equation. This should be equals to 10n. Now this equation has got two consecutive integral solutions. Then what exactly happens to n? Consecutive integral solutions means the solution should be of the form alpha and alpha plus 1, right, and both are solutions to this equation, right. So what we'll do, we'll start with assuming that there is some alpha and some alpha plus 1 which will satisfy this equation, right. What does that mean? If you substitute alpha in this one, this equation should be valid. At the same time, if you substitute alpha plus 1, then also it should be valid. And let's try to find out what exactly is this value of x that is coming out to be, if this is happening. If alpha and alpha plus 1 are solutions of that equation, then we can substitute alpha in the place of x, alpha into alpha plus 1, alpha plus 1 into alpha plus 2, alpha plus 2 into alpha plus 3, and so on should be equals to 10n. Similarly, alpha plus 1 is also a solution. So in the place of x, if you substitute alpha plus 1, then alpha plus 1 into alpha plus 2, alpha plus 2 into alpha plus 3, and so on, that also should be equals to 10n. Right, we have got two equations. What you will do, we will subtract the first one from the second one. Why you are subtracting the first one from the second one? Because these two terms, these two all will get cancelled. Only the final one of the second one and only the first one of the first one will remain. Right side will become 10n minus 10n will become 0, right? So these two will get cancelled, these two will get cancelled. We will be left with the final of the second and initial of the first. Okay, let us try to simplify this a bit. Alpha plus n into alpha plus n plus 1, this becomes alpha square plus alpha into n plus 1, that is this, and n times of n plus 1, that is this, minus alpha square minus alpha, this should be equals to 0, right. If you simplify this, alpha square plus alpha into 2n 2n plus 1, and there is a minus alpha here, so this and this will get cancelled, right, alpha into 2n, and this becomes alpha square will anyway get cancelled, so we are left with alpha into 2n equals minus of n times of n plus 1. This implies alpha equals negative of n plus 1 by 2. So far so good. So we figured out what exactly is alpha, in the sense what exactly is this x. Now we have to find out what exactly is n. This is not sufficient. Finding x is not sufficient. We have found x in terms of n, but what exactly is this n? Is this 5, 10, 20, 40, whatever? Right, how exactly do we find this? Now this is a summation, right? X into x plus 1 into x plus 2, so on should be equals to 10n. This is a summation. Let us try to solve this series. How exactly do we solve this? There are we can do it with in two ways. Let us try to do both of them. We have got x into x plus 1 plus x plus 1 into x plus 2 plus x plus 2 into x plus 3 plus x plus n minus 1 into x plus n. Right. Now let us try to finish this multiplication. X into x plus 1, we can write it as, this is nothing but x plus 0 into x plus 1, right? You can write it as x square plus x into 0 plus 1 plus 0 into 1, right? And this one we can write it as x square plus 1 plus 2 into x plus 1 times 2. Similarly, x square plus 2 plus 3 into x plus 2 into 3. So on, x square plus n minus 1, right? Into n minus 1 into n, right? So this is, like we discussed earlier, is set of quadratic equations, right? Now if we gather all the x squares, there are n terms here, so we'll get nx square, right? And all the x terms will gather 0 plus 1, 1 plus 2, 2 plus 3, finally n minus 1 and n. Similarly, the constant terms 0 into 1, 1 into 2, 2 into 3, up to n minus 1 into n, right? So this becomes nx square plus 0 plus 1, this is 1, 1 plus 2 is 3, 2 plus 3 is 5, so on. All odd numbers, right? First n odd numbers, right? The sum of first n odd numbers, x multiplied with sum of first n odd numbers, and then this pair 0, 1, 1, 2, 2, 3, so on, n minus 1, n. So this also has got n pairs, right? 1, 2, 3 up to n. Right. Now, this ones we know sum of first n odd numbers is equals to n square. Right. Sum of first n odd numbers which is equal to n square. Otherwise, we can easily prove this also. So, first odd number, second odd number, we can write the odd numbers in the form 2r minus 1. This is nothing but sigma of 2r minus 1, 1 to n. Similarly, this is nothing but sigma of 1 to n, r minus 1 into r. Right. So, let us do the summations of these two. This is nx square and sigma of 2r, that is nothing but 2 into sigma r, which is n into n plus 1 by 2, minus sigma 1 up to 1, from 1 to n, this is equal to n. So this simplifies to n square plus n minus 1, 2 and 2 will get cancelled. We are left with n square plus n minus n. So this simplifies to n square, which is what we are discussing. Sum of first n odd numbers is equals to n square. So for example, sum of first one odd number, that is 1 is 1 square, 1 plus 3 is 4, which is 2 square, 1 plus 3 plus 5 is 9, which is 3 square, so on. Right. And this becomes sigma of r square minus sigma of r, which is nothing but sigma of r square. Sigma of first n square, sum of squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6, and sum of first n natural numbers, this is equals to n into n plus 1 by 2. Right. So now where are we? This simplifies to x into n square plus n minus 1, which is equals to x into n square, and this also simplifies to n into n plus 1 by 2 into 2n minus 2 by 2. So this we can further simplify. Nx square and xn square, n into n plus 1 and 2. Here we can take 2 common. That 2 and this 2 will get cancelled, n minus 1 by 3. Right. Now earlier we had already figured out that x is equals to minus of n plus 1 by 2. Now we will substitute this x equals to minus of n plus 1 by 2 in this equation. So n times of minus of n plus 1 by 2 whole square, which is nothing but n plus 1 by 2 whole square, minus of n plus 1 by 2 in the place of x into n square plus this entire expression. This should be equals to 10n, right? Which is what our original equation was. Now let us try to simplify this a bit. Here there is a n, there is n square here, there is n here, there is n here. We'll try to cancel all of that. We'll be left with n plus 1 by 2 whole square minus n into 1 n will go, n into n plus 1 by 2, and n plus 1 into n minus 1 by 3 equals to 10. Right? Now here we will take n plus 1 common. We will be left with n plus 1 by 2 square, which is 4, and we will be left with n by 2, and we will be left with n minus 1 by 3. This should be equals to 10. We can further simplify this. We will further simplify this basic algebraic manipulation, and finally we are getting n plus 1 into n minus 1 equals to 120, which is nothing but n square minus 1 equals to 120. We got n square equals to 121 and n equals to 11. So we figured out what exactly is n. N is 11. This is one method. There is another method which we can use to solve this kind of equation, this kind of summation. Here our goal is to find summation of x into x plus 1, x plus 1 into x plus 2, x plus 2 into x plus 3, so on and so forth. Right. Before we get into x in terms of variables, let us do with small numbers. Say for example, in a series like 2 into 5, 5 into 8, 8 into 11, etc. etc. So this series is nothing but 3n minus 1 and 3n plus 2. Right. The series, the difference is actually 3. Right. This is kind of arithmetic progression, 2, 5, 8, 11, 14, so on, right? So the first term is 3n minus 3 minus 1, and 3 into 1 minus 1, 3 into 1 plus 2, 3 into 2 minus 1, 3 into 2 plus 2, etc. Right? Now, to do this summation, let us try to write each term as difference of two terms, right? Which is again an expression in terms of n. So what I mean to say is, so for example, this 2 into 5. This 2 into 5, if there was one more number before 2, that would have been, it would have been minus 1, right? 5 minus 3 is 2, 2 minus 3 is minus 1. Similarly, if there was one more number, 8 minus 5 is 3, 5 minus 3 is 2. Right, let us create another series. The original series we call them as u1, u2, u3, so on, un. Similarly, the created series we call them as v1, v2 up to vn. Right, how we are creating? We are just attaching one more number, which if we had extended this one, the number that we would have got, right? 5 minus 3 is 2, 2 minus 3 is minus 1, 8 minus 3 is 5, 5 minus 3 is 2, right? And how does this help? How does this help is this 1 minus this number, v2 minus v1. This becomes 2 and 5 is common to both. 2 times of 5 times 8 minus minus 1, which is equals to 9, right? Similarly, v3 minus v2. What you will get? 5 and 8 is common to both. We'll get 5 into 8 into 9, right? So, essentially v3 minus v2 is 9 times of u2. Similarly, v2 minus y1 is 9 times of u1, right? So, what does that mean? We are able to express u1, u2, u3 all in terms of differences of v's, right? So, for example, u1 we were able to express as v2 minus v1, u2 we are able to express as v3 minus v2, u3 as v4 minus v3, etc. Right? So, u1 is nothing but v2 minus v1 by 9 and u2 is nothing but v3 minus v2 by 9, etc. And un is nothing but vn plus 1 minus vn by 9. And how does this help? How does this help is, a lot of terms will get cancelled. Now if we do the summation, u1 plus u2 plus u3 on up to un, we'll add these terms, right? These terms. So 1 by 9 into v2 minus v1, right? v2 minus v1, v3 minus v2, v4 minus v3, so on vn plus 1 minus vn. Now here, all lot of terms will get cancelled, v2 and minus v2, v3 and minus v3, v4 and minus v4. We will be left with only the vn plus 1 in the final pair, and minus v1 in the first pair. The final pair this one and first pair this one. We are left with 1 by 9 of vn plus 1 minus vn. v1. So, but what is vn plus 1? We decided vn, earlier we decided vn is nothing but this. Vn plus 1 is obviously 3n minus 1, 3n plus 2 and 3n plus 5. Right, vn plus 1 will start with this and the subsequent number. And what is v1? v1 is nothing but this number. Right. So, now this is the summation. This is the summation of the u1 plus u2 plus u3 up to un. Now, the same idea we'll try to use instead of this 2's and 5's if there were x's, right? We will use the same process. This time we'll assume this as u1, u2, u3 up to un, right? We'll again create another series. We will call it as v1, v2 up to vn. We'll multiply this first term with a number prior to this, right? This is x plus 1, this is x. The number prior to that should be x minus 1. Similarly, x plus 2, x plus 1, the number prior to that is x, right? We'll create the series of v1, v2 up to vn. Now we'll do the same thing like we did earlier. v2 minus v1 should be equals to some constant into u1, right? v2 minus v1 is x into x plus 1 times of x plus 2 minus x minus 1, which is equals to 3. Similarly, v3 minus v2 is u2 into, again the same constant, 3. So now u1 plus u2 up to un should become 1 by 3 of v2 minus v1, v3 minus v2, etc. up to vn plus 1 minus vn, right? We are doing exactly the same thing. We are creating a new series, but the difference of new series is some constant multiplied. Difference of two terms of the new series is a constant multiplied by the numbers of the original series, right? Now this means again we'll be left with only vn plus 1 and v1, which is in the beginning. So 1 by 3 of vn plus 1 minus v1, this should be equals to 10n, right? But vn plus 1, like we decided, Vn plus 1 is x plus n minus 1, x plus n, and x plus n plus 1. And v1 is nothing but our original x minus 1, x and x plus 1. Now this should be equals to 30n. Right, now we have to figure out what exactly now we have to figure out what exactly is our n. Now, but we already know x in terms of n, right? So what is x? X is minus of n plus 1 by 2. So what is x plus n? X plus 1 is minus of n plus 1 by 2, which is minus n minus 1 by 2 plus n, which is equals to n minus 1 by 2. We'll substitute this here and here and here and here. Okay. Now, x plus n is n minus 1 by 2. So we'll substitute n minus 1 by 2 here, n minus 1 by 2. If you multiply this, x plus n into x plus n square is x plus n whole cube minus 1 times of x plus n. Similarly, x cube minus x, right? Minus of x cube plus x. Now we'll substitute in the place of x plus n this n minus 1 by 2, n minus 1 by 2 whole cube. N minus 1 by 2 whole cube minus of x plus n is n minus 1 by 2 and n plus 1 by 2. X is minus of n plus 1 by 2, right? Minus of x cube will become plus of n plus 1 by 2 whole cube minus plus x is minus of n plus 1 by 2. Right, we'll gather this and this. This is in the form of a minus cube plus a plus cube whole by 2 cube, which is 8, and we'll gather this and this. Now a minus b whole cube plus a plus b whole cube, if you simplify, then a lot of terms will get cancelled. You will be left with 2n cube, right, and 3 plus 3, 6n. Here remaining 2 terms will get cancelled, and here we are left with 1 and minus 1 will get cancelled, minus 2n by 2, which is equals to minus n. Right, here we can further simplify this. We can cancel n and n here also. So we'll be left with, and 2 and 6 is there. We can simplify this and we'll make it n square plus 3 by 4 equals to 31, which is nothing but n square plus 3 is 124, n square is 121, and n equals to 11. The same answer that we have got earlier also. So we figured out 2 ways of doing this summation. The summation of x into x plus 1, this summation. We have figured out 2 ways. Whichever way you feel is easier, you can actually do that. Right, guys?